Find 2 to the 4 without your calculator. And just, girls, just tell me, what are you going to do to find it? 2 2s are 4, 4 2s are 8, 2 8s are 16, is 16. All right, take a moment, think before you answer. What's negative 1 all squared? Good, negative times a negative is a positive. What's negative 1 all cubed? Beautiful. So using that idea, do you know what negative 1 to the 10 would be? Beautiful. So negative 1 to an even power is 1, and negative 1 to an odd power is negative 1, because that last negative doesn't have anything to cancel out with. Excellent, girls. All right. Now, girls, I want you to look at E carefully, though. What is actually to the power of 5? Only the 2, not the negative. For me to have the negative to the power of 5, you needed brackets. Okay? So negative and then 2 to the 5. What's 2 to the 5? Does anyone know? 32. And so what's my answer to that? Beautiful. So these are skills we need to have without a calculator, which you seem to already have. What's 4 to the 0? 1. Okay, anything to the power of 0, anything at all, is 1. Might just do a G. Does anyone know what 2x to the 0? Because x to the 0 is 1. So it's like 2 times 1, which is 2. Is that all okay with everyone? Excellent. What would I have to do to make it all equal to 1 in that question? Like what would I have to change about the question? Brackets around the 2 and x. That would be 1, but it's not that. It wasn't that. Anyway, let's keep going. So that's good. The summary of index laws, if you've forgotten them. When you times 2 things with the same base, you add the powers with the same base. We're having the same base on the bottom. Division, you minus the powers. Power to a power, which is this one here, you times the powers. A times B all to the n becomes A to the n times B to the n. You just put everything in the brackets to the power of n. Similarly here, A on B to the n is just A to the n on B to the n. And look at this one. A on B to the negative n, well, the negative means you flip the fraction. And then put it all to the n, and then that becomes it similarly B to the n on A to the n. What's 2 to the negative 3? Which is actually 1 over 2 cubed, is that correct? 2 could be written as 2 on 1, right? So to get from there to there, I could think of it as flipping the 2 on 1 and making it a positive power. Would it give me the right answer? That's what I'm asking you. And then 1 cubed is just 1, 2 cubed is 2 cubed, or eventually 1 on 8. My point is, if it works for that, then it works for this. So when I've got a negative power on a fraction, I flip it, then I make the power positive. So that's what you got to take from that, okay? A to the 0 is 1. A to the negative 1, I think you know, is 1 on A, and A to the negative n is 1 on A to the n. Similarly, 1 over A to the negative n, the negative on the bottom brings it actually up and it becomes positive. All these skills we need to be very good with. Okay, now let's have a go at using all those skills to simplify. Notice, girls, even if this was a paper 2, notice the word simplify. Simplify doesn't mean give me a numerical answer. It means write as a simple index notation. Is a simpler way to write 4 to the 3 times 4 to the 7. Yes. I was about to do 4 to the 21 and that would have been wrong. Now, girls, why can't I right now say it's like 16 to the x for B? Why is that wrong? Not the same base. I can't just multiply anything. I need the same base. So 2 to the x is fine. There's nothing I can do there. But can I write 8 as with a base of 2? What would that be? 2 cubed, right? 2 to the 3. So now, what is that in one number to a power of something? Good, x plus 3. You add the powers. 2x all cubed. 2 cubed is 8. X cubed is just x cubed. Can't do anything with that. D, you might think, oh, that's already simplified. Technically, it's kind of like B. If I can get them both in terms of base 3, I can use my index law for division. Does that make sense for D? So The numerator is already base 3, so I'm fine with that. Take a moment, think. Try not to touch your calculator. 3 to the what is 81? So that becomes 3 to the 4. All right, so using our division property, what does that become in an even more simplified way, Sophie?
3 to the t minus 4.
Beautiful, t minus 4. All of that, negative 2a to the 5 to the 4. I like this part. Why isn't it negative? Even power means it gets rid of the negative. All the negatives cancel out. All right, F. Now, don't tell me the answer. Just tell me one thing I can do with F. Yes, it's a positive to the positive 2. I always do that first, and now I'll square it. Beautiful, yes, good. Question 3. Girls, I want this rewritten without any negative indices. So you maybe look up, what do the negative indices do if we're at the top? What does it do? And what does it do if we're at the bottom? Take a moment. Just tell me what I should do with the A part. Hands up. Where should this go so that I get rid of the negative indice? Look, and it's on your page. The clues are on your page. Everything's there. Alicia? Yeah, and then it becomes a squared in the denominator. What about B? It can stay. It's fine. What about C? Needs to go to the numerator, and it becomes C to the 1 or just C. Is that okay? Beautiful. Write this in non-fractional form. So I just want, in other words, I just want A to the something. I don't want it to be in a fraction anymore. Basically, girls, let's do an easier one. What about if it was 1 over A cubed? What would that be if I got A outside of the fraction? Or brought A up from the denominator? Think of it that way. A to the negative 3. So you just negate the power. Is that what you're telling me? Same thing here, but it's just a more complicated power. And then that equals A to the... Oh, I like that. N minus 2 instead of negative 2 plus n. It's just a nicer expression. But negative 2 plus n would be 100% correct as well.